supervised fine tuning and all that stuff. But in practical applications, we'll never do that, isn't it?
Yeah,
That
yeah.
we would rather learn the templates. I mean, there's so much of software engineering that has gone over the LLMs.
Hmm.
It's ultimately it's all software engineering, isn't it? Uh,
Yeah.
the wrappers and workflows and whatnot.
Hmm.
So, I mean, this book is short on those stuff.
Yeah, yeah. Yeah. So should we, like, after this chapter, maybe we can find some other book that's more recent?
Are you guys only going to do books? I would rather suggest some of the courses.
Yeah.
So learn the course, and some of them are really good,
Mm-hmm.
and then take it up from there. What do you want to do? Do you want to explain one of the apps that you make, something like that, or just explain section by section courses,
Yeah.
something like that.
Do you have any courses in mind? Maybe we can discuss, like, different options, right? On
Yeah.
select.
So
Yeah.
let me share my screen, and then oh god, I just wanted to share something, but it's not happening.
Yeah. Deep Learning AI has some like new courses. We can pick one from there, but I don't know if all of them are free. Looks like it's free.
Yeah, deeplearning.ai has lots of courses, and that's what I was. Oh, what has happened? I have.
Yeah. Hmm.
Okay. Yeah, so deeplearning.ai has a lot of them. That's what I was thinking. Though those are short courses that we could start from, and this one that has come up, the Claude Code, a highly agentic coding assistant. Okay, we could have just gone through this and made something, or somebody, and presented. The other one is the Hugging Face courses.
Hmm.
So if anybody is interested, I know when we go to Hugging Face, it might get intense, and we will lose some of the audience because of that.
I think we need to keep it interesting. So, like, for all different kind of roles, right? Not only just developers, but product managers and architects.
Yes.
It's relevant, right? Yeah.
Yeah. We can. I mean, we can start from deeplearning.ai and then maybe take it from there.
Okay. I think
Okay.
let's start this chapter, and
Yeah.
then maybe towards the end we'll discuss what to do next.
Yeah. All right. So this is my chapter, the image captioning, and as such, I had written that there are shortcomings in this chapter, and some of the shortcomings I'll explain later. But let's start with the why image captioning is needed and why is it important. So image captioning has a multiple applications on social media platforms. We can, content creators can make it faster. Then NSFW content moderation can be helped with this. Then there is a cold start problem that happens when nothing is known about an image or a video, and at that point of time we can do the image captioning and know and sort the videos, sort the images by generating the image captions. So the very first thing that I like about this book is that it gives in the end it gives the summary, which is more like a mind map kind of a thing. And I tried to make that mind map on my with by myself. So the very first thing that they always do is clarifying the requirements, and then making it as an ML task, and then actually dividing the model development into architecture, training, then doing the evaluation with sampling and online sampling, offline, whatever, and then telling about the overall system, how it works. Because most of the time when we fall short of time and we do not cover this overall system components. Let's do the clarifying requirements. So every time when they clarify the requirement, it is, when we are giving an interview and we are clarifying the requirement, then it is good to ask such questions. I really like these questions, that what would be the input. Since we are starting on the images, what would be the size of the images? Because that is very important. If we make the image size very small, then not a lot of interpretable information is there. If it is too big, the data set will be just too big and cumbersome. So the input images, what kind of images to focus on, the general everyday images. And then there is always a question about the use case clarification. Well, who is going to use the system that you are making? And in this case, when they say who is going to, then the interviewer says that it is for designers. When they upload their images, then those images can be captioned quickly. There's a discussion on caption format. It should be short and descriptive, English captions only. And in this case, they also discuss the latency, because they say that a latency of 1 to 2 seconds is acceptable. And then the candidate has asked about the data set, how processed the data set is. And in that case, I think the interviewer has said that there are 400 million, I think. Yeah, it says that the data set is not pre-processed. So in text as well as in images, more so for images, there's a lot of pre-processing that is needed. So the interviewer has already warned that there might be captions in different languages, and some captions might be noisy, images might be missing, or images might be blurred. So, and then the candidate actually clarifies what would be the output like. So then skip ambiguous content, no captions with offensive words, and fair and safe captions. So, since this is a book on ML task, then framing as an ML task is an obvious thing. But in this case, there'll be an image encoder and a text and decoder. So that thing is confirmed over here. Then comes the data preparation. What kind of um, how do you hide this? Because I think you guys might not be seeing that this caption is coming. How do you
You
hide
can
this
actually
screen?
you can exit out, I think, on the corner, right? Yeah.
Okay. So yes. So while Okay, so the data preparation is important, and they took a long time to discuss what kind of data preparation would be done, how the caption would be prepared. So the data set is of 400 million pairs of images. However, not all images and captions are suitable for training. So then this caption preparation is remove pairs with non-English caption, remove duplicate images, remove irrelevant captions. And in the duplicate images and all those stuff, they are saying that they would be using the clip encoder. Uh, for image similarity. They can remove the duplicate images by knowing that if the images are similar. And for that, they are using the clip text encoder. Then,
Uh,
yes,
but Shiva, here, like duplicate image detection may be costlier than just generating the caption, right? If let's say you have 10,000 images, out of them, half of them are duplicate.
yes.
Maybe it's better to just generate double the amount of caption instead of trying to remove the duplicates.
Yeah, valid. I mean, what happens is that we try to do image augmentation, and so we can treat it as like augmented images. I mean, since we are noting the similarity, so if they are exactly same, then maybe we can remove those. But if there is a semantic similarity, we can keep those. That can be done.
Mhm.
What is your suggestion? Not even run through those clip text encoder.
So I think it depends on what is costlier operation, right? If image duplicate detection, actually duplicate detection, in my mind is a like n square problem, right? For every image, you're trying to
Yeah,
figure out among the n images if it's a duplicate, right?
yeah.
But
Browsing through the whole of n, so yeah,
yeah,
makes it O n square. Yes.
yeah, and but the caption generation might be cheaper than that. We are just detecting objects, boundaries, or trying to figure out what objects are there. So if a caption generation itself is cheaper, then just skip the duplicate detection and just generate the caption for all of them.
Yeah,
Like
yeah, yeah.
practically, probably I would take that approach, but again, it depends on which operation is costlier.
Yeah. So the problem is that I mean I think the chapter has not mentioned, and this is the shortcomings, that image needs a lot of preparation. So and here when it has mentioned that 400 million pairs, and that is not a good data set, where there's a lot of images and captions are missing and all that stuff. So then there is a data preparation that needs to be done. So yeah, we can remove this part, that don't duplicate, but there are other things that we need to do to make the data set safe, like irrelevant captions you'll have to remove. If you are giving long captions as an input, then the your image caption generator will go wrong. It will not have the right ground truth to be based on. Then in the yeah, so those things, tokenize the captions, that byte pair encoding, that is needed for everything. So that's not that we can remove. The other image preparation is a very very big task according to me, because I have done it so many times, that remove low resolution, normalize the images, remove low quality images. So at this point of time, they say that there is an image quality assessment method, such as Leon aesthetic predictor, that can remove the subpar images. Like suppose somebody has just made the emojis bigger, you know, and what would you do about a big emoji of 256 by 256? That can be removed. The image dimensions, when we do a resizing, we cannot just resize an image of a different aspect ratio. You have to do kind of a center cropping, and the belief is that when you do the center cropping, you are actually taking in the meat of the image while leaving out the other remaining stuff. So yeah, that ends the data preparation. The model development, uh, they are already set on architecture that it has to be an image encoder, and while doing the image encoder, also there has to be so CNN based. People used to use CNN based image encoders, but of late they have stopped using the CNN based, and they actually use the transformer based nowadays, where they actually take the input image and then patchify it. Okay, it's here. So then patchify it, positional encoding, and then give it to transformer, and the embeddings are actually sequence of embeddings, which are 2D positional encodings that they'll use. I hope I'm not going too fast for you guys, or and I'm not skipping a lot of stuff.
This is good.
Okay. Yeah, so basically patchify is divide the image into fixed size patches and then flatten them and then linearly project each patch. So this is what they do. And hoping that each patch will actually give a semantic meaning out of it. Uh, Here too, I feel that there should have been more progress that would have happened in this year's time, because just doing a patch of input image will might not work, because let's say just a face or just a cat comes in the middle, but when you patch it, it'll not show how many cats, how many faces are there. So still the transformer based image encoders lack this uh, this information, or they still lack. Even GPT-5 lacks this information. So yeah, so this was that they decided on 2D positional encoding, and I think this is often based on learning versus fixed, different combinations. Okay, let me see what did they use. So they also say that instead of training an image encoder from scratch, we can leverage powerful pre-trained vision models like CLIP and Vision Transformer. And yeah, so the text decoder is the same that we have discussed in the previous chapter. So nothing changes over here. The training, let's talk about. So in the model development, we have covered the architecture. Let's talk about the training. Um, so the unsupervised pre-training, the pre-training stage will be two types. In the text, pre-training will have to happen for the text decoder, as well as the image encoder pre-training has to be happen. Uh, so in this case, they are saying that we will take pre-trained decoder only transformers such as GPT-2 in this case, or Llama. Um, and at this point in so many chapters that they are mentioning that they would not do a pre-training. It is computationally expensive, and they would actually go with the already pre-trained transformer or the image encoder such as clip or vision transformer. So supervised fine tuning, they mention. So in these chapters, I have always liked that they have, whenever they are mentioning what kind of training they are doing, they are always mentioning the ML objective and as well as the loss function, because that is the most important thing while training. So in the supervised training, it says that we train the image encoder and the text decoder on 400 million image caption pairs. Uh, And the ML objective, they say, is actually just the next token prediction. Because if we look at this, here the image is coming as well as caption, the ground truth caption, and there is a predicted probabilities and cross entropy loss, and then the correct next token is predicted. And this flows down, and that's how the loss is computed. So let's come to the sampling. How do we do the sampling? It says that there are a lot of sampling methods that are there, but in this case they are going to do a beam search, and beam search because there is a consistency issue that might happen for the caption, so they want to be consistent on the prediction, and as well as coherence also. They want to predict the coherence needs to be the same as well as the quality, so they went for the beam search. um, Here too, if I have to mention, coherence would be a very big problem. I mean, even if they are saying in this diagram that every time the image encoder patch will actually predict, when we say a flower, the way these patches are there in the image encoder, a flower might not come. So even I'm not sure that cross entropy loss would be done like that. Maybe they can help with that, but it has to be a whole caption generated once and then do a loss on it. But first, when the caption is generated, sort it semantically, maybe arrange it semantically. That is not mentioned, but I feel it cannot be done without it. Does anybody have an opinion in this?
Sorry, Shiva, can you repeat what he just said?
Um, so I said that the way that they have mentioned how the supervised fine tuning is being done to generate the caption is that this is exactly the diagram, isn't it? That
Yeah.
an image encoder is employed, and it does this. It gives you the image embeddings. The image embeddings is actually it is we have already talked that it is we do a patchify of
Yeah.
it, and then so if it is a 256 by 256, maybe a 64 by 64 patch, then it becomes a 4096 embedding after flattening, and
Yeah.
then it gets projected and then it becomes an image embedding. My thing is that each embedding it will not give you an next token description such as a flower icon, because sometimes that flower is not let's suppose this flower is a 256 by 256 image, and it won't be able to know
Hmm.
by divided patches that there is a flower. The flower will only come to a projection once you have gone through the whole thing. So
Yeah.
let's say here when we are doing a cross entropy loss, it might not, next token prediction might be something very very different, you know.
Hmm.
And instead of doing a cross entropy loss on the next token prediction, they might have to assemble the caption and then do a cross entropy loss on it.
Yeah,
And they are not mentioning it, but that might be a better way. Because otherwise, that caption might not be. They'll have to arrange the caption semantically. So even when this image encoder gives you a patch, it might just say a leaf or a flower petal or something, and that might get floated as a token.
yeah, I agree with that. But when you're generating all these embeddings, right, for individual patches, I
Mm-hmm.
think it's taking all of those embeddings into the context, right? It's not like just with one embedding, it's trying to generate the text. If you
No, no,
see,
no. So that's
yeah,
the text decoder. That's what it is doing, isn't it? Ultimately, it is doing yes, attention, multi-headed attention
right,
on it,
yeah,
isn't
yeah,
it?
yeah,
So with the multi-headed attention, it might know that this embedding is saying this part or this part, but I'm not sure that it will get the whole caption in the series,
I see what you're saying. Yeah.
in the series in a semantic way.
Hmm.
Well, I still feel that they might have to do a combination or preparation and then do a cross entropy loss. This is my feeling. I mean, I don't know the truth about it though, because you'll not find material on it. Nobody is doing image captioning in a separate way.
Hmm.
But
And if you use that, let's say that clip kind of model, does
uh-huh.
it still generate multiple embeddings for the given image, or does it generate only one embedding for the given image, and that has all the context?
No, it will generate. So clip will actually do a text generator, isn't it? Image encoder from yeah.
Clip is the image encoder, right?
Yeah, clip is the image encoder or vision transformer. Yeah, it is going to give separate embeddings for each patches
Oh, you're
actually.
saying that we'll still create the patches, but instead of running through our model, we'll use clip to generate the embedding for each patch.
Yeah,
So if
that's
let's
what
say
is
one,
happening, isn't it?
okay,
So yeah, sequentially, isn't it? That's how the text sentence will go, and that's how this image patches will go. They are going together
yeah, I
in
know
this
that
in
part I
this
got.
way.
What I was not clear is that is clip replacing the whole image encoder and then patching and dividing that part also, or is it
Yeah,
only just the embedding generation? So seems like you're saying is that we still need to divide the image, and we need to feed each patch to clip to generate the embedding for each patch, right?
yeah,
Okay,
that's what I feel,
okay.
but might be wrong. I'll have to come back on this.
Yeah, earlier I understood that uh, maybe clip was taking the whole image and it's generating one embedding, uh, but that might not be correct because one embedding may not capture all the objects that could be like present in the image, right? Image could be very noisy. So maybe what you're explaining is right, that
Yeah, there
we
are
still need
multiple
to do it.
embeddings
Yeah,
that I'm sure of
yeah,
because
yeah,
those, yeah, there are multiple embeddings,
yeah.
and they might not be a one-to-one correspondence with your caption too.
Oh yeah, that's for sure. Yeah,
Isn't it? Yeah,
yeah,
because if the caption is longer or shorter, it might those embeddings might not be a one-on-one.
yeah.
Uh, okay. Yeah. So we talked about the sampling, which is beam search. Then the evaluation is uh, they say that they are doing mostly an offline evaluation, and because um, you know I want to have multiple reference captions. Yeah. So the problem is that they always say that there might be different types of multiple captions that might be generated, and so they want to do a, um, kind of a how much match is there with the several captions that are reference captions that are there. So what is the match? And this way they are actually saying that the training and evaluation is more comprehensive. So they basically say that there are several metrics, which is the same that we have talked about, the blue, rouge, and meteor. But in this chapter, they are very particularly trying to talk about cider. And they say that the cider gives higher scores to captions that are similar to multiple reference captions, so that they are not stuck to just one mention of the caption. So in this case, they uh, represent the captions, the several captions that are generated through a TF IDF. It is a numerical representation, and then calculate the similarities and then aggregate the similarity scores. And once those scores are aggregated, in this in our case there are three references that are there: the blooming tulip with leaves, a blooming tulip, single tulip with leaves. And if a generated caption from our side is tulip with leaves, then what is the similarity? And if it is that similarity is of a certain threshold, then it is a pass. It is then it becomes a cosine similarity score of 1 indicates greater similarity, while lower value closer to 0 might indicate lesser similarity. And that's how they are going, that is a metric that they are going to use to evaluate the image captions. So in this case, they mention how they aggregate the CIDR score, and there might be some images, some captions that might have a higher similarity, some might have lower similarity, but on aggregation it is above zero point 0.5, and then they would say that it is a good score. So the pros of this is that it is consensus based, sensitive to important words, and robust to different caption variations. The cons are that it would be if even if we decide that we are going to compute with three captions and not more than that, they are still computationally complex, and it's sensitive to the quality of reference captions that we might have generated, or we as the ground truth we have. Then even if the image caption generator actually generates something novel, it will get penalized because it might not be there in our ground truth caption. And there might be a problem of semantic understanding. For example, this was what I was talking about, that even when the caption is generated, there has to be a semantic way of generating it, or permutation combination to happen after the sentence, after the caption is generated, so that coffee on top of the table, or table on top of the coffee. Like this sentence does not happen, table on top of the coffee. So on the online, they say that they are often not the primary focus in image captioning systems, because image systems are usually part of a bigger system, and that was my biggest problem with this chapter, that we are always part of a bigger system. So how do we, create just one image captioning transformer? Then the second is that collecting feedback from users would also be challenging. So, then we come to the overall ML system design. and how would you actually assemble everything. So you've now pre-trained a caption generator. You have cleaned all the images, image pre-processing happened, you trained the caption generator, and here we now there's a trained model that is there. How are you going to employ it? So the overall here they're just saying that how what all we went through, the input image pre-processing, caption generator, and then we did a beam search to evaluate the trained model, and then there was some post processing also done to get a good image caption. So it actually gives a summary here. The caption generator is the core component that produces captions based on the prepared image, and the component interacts with the train model and employs beam search. This is when this is used. So this would be how we would actually use our system. That we would give an input image and we will have to pre-process it, and the caption generator uh, will generate it, interact with the train model, and do a beam search on it, and then do a post processing.
So, in this overall ML system design, uh, can this trained model be replaced by any multi-model?
Yeah, actually, it can be used. I mean, I so it says that this will always be part of a bigger system. So train model can be used, can be replaced by anything right now. I mean, all these are multimodal systems that are there. GPTs, Claudes. You could replace it by anything. You can give an image, isn't it? We give documents, we give images to GPT, and it just generates the caption if you want. There won't be a problem in that. Yeah, so that was the other thing, that shortcoming system can't count, and even true for the latest GPT-5. Post processing is mentioned only cursorily in this chapter, and I feel that that would be a more it would be very comprehensive. Uh, and yeah, the chapter is kind of mute, as nobody will develop a solo image caption generator at this point.
So they also talked about low latency earlier. How are they addressing low latency here?
Yeah, they after they say that there is a low latency, they haven't mentioned the latency of the system later on.
Yeah.
uh, they feel that by employing all of this, they should be okay. I mean, the already the image preprocessor, the clip and all, and then using the train model, they should be okay.
Hmm.
So, can
But
we use other computer vision libraries like YOLO and other stuff to generate the sample captions and then uh, compare it with the whatever is being generated from the trained model?
yeah, I don't think YOLO ever generates a caption.
But YOLO can provide you the objects which are
Yeah.
available in that image, right? So
Yes,
at
yes.
least you can get those entities, and then based on those entities correction, you can generate a caption. For that, we can use
It's
LMs.
very hard to do from YOLO come here to this place. It seems
Yeah.
hard.
Yeah.
It
Maybe
seems
you can
hard.
do some, you can use that for some data preparation, right?
Yeah,
Like earlier we were doing that, cropping the image to 256 by 256. Maybe
Mhm.
with YOLO you can detect that, oh, here is the actual object. Maybe it's in the corner, and
you
clip
could do
only
that.
that part, right?
You could do that.
Yeah.
Yeah, you could do that. Maybe the center is empty and it
Yeah.
is on the side. that generation, that information you can have.
Yeah.
So, do we want to discuss GPT-5, or GPT-5 is was a big dud, and I mean everybody's saying, isn't it? GPT-5 is didn't work out.
Yeah, I think there was a lot of hype around it, but in practice, I think like I'm experiencing that when they generate the response in GPT-5, it looks more AI generated than
Really?
yeah, it looks more formal and not like regular human speaking English in that language.
Hmm. Yeah, let me see what I wrote on GPT-5. Maybe I can uh, yeah, let me share it again. So
And then I don't know why were they in such a hurry to remove other options, right? Whenever they release earlier models, they have always provided options to, if you wanted to go back, you could go back to like 3.0 or 4.0, all those models, right? But with GPT-5, they removed all of those options.
This
The
might
cost,
be their marketing strategy to promote GPT-5.
so simply is the cost optimization. पहले मतलब we used to default to a best model, तो उसका cost
Mm-hmm.
हमेशा ज़्यादा था and we were paying only $20, right?
Mm-hmm.
But अभी ऐसा है कि they are defaulting to a model and they will do deep thinking only when necessary और वो करेंगे भी नहीं, ठीक
I
है?
see.
hmm. Yeah,
तो
so this is what they are mentioning, isn't it? The router model is there, and every all the other models are behind that
Mm-hmm.
now. So if even if they go ahead and use a very primitive model, we'll not know because it's now the GPT-5 that is deciding, because it's a unified system.
but a problem is, ma'am, you lose the control, right? Now you are not
Yes,
deciding which model to use.
yes.
GPT is deciding and you don't know when, correct?
Yeah, yeah. You don't know. It is deciding on various factors. Maybe that what was that thing that people were doing, the glyph, or what was that, that they were making, the
Yeah,
cartooning, the
Ghibli images.
yeah, the Ghibli image, and people were using, Sam Altman had said that it is burning. GPT, the servers are burning, the data centers are burning because of this. So, here I see that there is a good use, that they might give it to a smaller model to use that. But I think when you do a pro, or pay for it, you might have a better control on what models you're using.
So here GPT-5 thing is acting as a supervisor. Means they can decide uh, what model we can use to generate the responses. So that is that the reason they are telling they have embedded this thinking and the reasoning capability into it.
No, thinking and reasoning were always there. Thinking models, they used to tout them as different models, isn't it? The thinking or O1 and all those were reasoning models. So uh, that was always there. I think if they're saying that it is reasoning more, I'm not sure about that. But the only thing that is there is this real-time router that they are using, and that router is now in their control. Maybe if there is less bandwidth, or a less paying countries or something like that, they can actually switch it to a smaller model and never let it use their bigger models.
Like thinking model is pretty similar to O3, like जब
Yeah,
इसके
O3. Yeah, O3.
O3 has been replaced with thinking model, but if someone was doing deep analysis every time, they can go and change in the setting also. Like एक तो router का option है, but if you go to GPT and setting, right? you can
Mhm.
enable the thinking mode always. Like for every search, you can enable the thinking mode. So by default, every time it will do the deep thinking. So a routing ka kind of you can move away from the routing part that way.
Yeah, yeah. So I thought that it is mainly for the paid customers. It is for the general customers too.
मैम मैं तो पेड कस्टमर हूँ तो मुझे पता नहीं कि
Yeah,
जनरल
well,
कस्टमर को क्या सेटिंग दिख
that
रहा है.
that's a whole thing that I believe that since these are very token expensive models, isn't it? Unpaid customers will very quickly go reach the threshold.
हाँ तो आई थिंक थिंकिंग मोड इवन द अनपेड मॉडल पीपल कैन लाइक plans can enable but limit is on the token size so कि
Yes,
उसमें
yes.
टोकन अगर आपको ज्यादा लग रहा है तो फिर आप बहुत जल्दी लिमिट हिट कर देंगे.
The problem is that whatever token they are generating by asking a question, there always a big wrapper around it, isn't it? That we are that router function and whatnot will use those extra tokens. So the user will reach that threshold very soon. Yeah, so
Uh, but
there was one more thing that they said that there was this parallel tool calling while coding with GPT-5, and which is I think important. Which might be it is a technically more capable tool.
कोडिंग के लिए तो आई थिंक कर्सर प्लस क्लाउड इज द बेस्ट वन. Still like
Yeah,
GPT is still catching up with cloud on the coding side. So if
yeah, that's
anyone
true.
wants to use for the coding, Claude is the best option to go
Cloud
with.
is the yeah, Cloud Code is the best. Yeah, that's
Even
true.
recently it was in news that GPT is using Claude to train their model for the coding.
Okay, that's good.
One thing I wanted to check if anyone's using Copilot to build any end-to-end workflow in Copilot Studio. Has anyone tried that?
So Copilot like just generating the small code or how
नहीं
I,
सर, कोड जनरेशन नहीं. एक तो कोपायलट है जो आप टीम्स में मतलब अगर आप किसी कंपनी टीम्स यूज करती होगी मतलब माइक्रोसॉफ्ट तो कोपायलट आता है एक ऑप्शन. देयर
uh,
इज वन फीचर कॉल्ड कोपायलट स्टूडियो.
mhm.
So build end-to-end workflow similar to what you do in N8N. So I'm just trying out. I had a few things stuck at one place, but
I have seen some video earlier like Copilot Studio how they like you are right like that you can create the workflow like you give your project requirement it will create everything for you it will create the UI it will create the database design everything you can do that Copilot Studio that was looking very impressive like this like and it is
uh,
used in the Microsoft Power Platform also same thing that kind of thing yeah that I
so
have
now for me look like things going now out of control. Out of human hand. And even now we in the process of the people are in the process of learning these agentic framework to develop the workflow. Now people still struggling to learn it. Now the another tool came that can develop them. There's already automation came for data. That's what you're trying to say. I heard about it. I didn't use it, but this is the first time that I heard that somebody you're trying that even you can generate the agentic flow using the AI itself. Then where will be our role? Okay. So now currently for personally me, I'm just trying to learn this framework, trying to apply in my current support project so that all the agentic flow I'm trying to develop it so that we can do the whatever we are doing the support work we're trying to replace it okay using this framework. But now you are saying that there is already something there that you can build by using with the help of AI itself.
हाँ तो मतलब even rack pipeline, right? If you go to Copilot Studio, it
Mm-hmm.
just say there's a knowledge option. You just upload the document. You don't need to create any vector DB. You don't need to worry about optimization. Just upload your document, and your rack pipeline is ready now.
Oh,
Yeah.
So
Mhm.
so
even I will recommend. There's a I think Databricks generative AI course.
I
It's a
think
very good course.
autopilot. I think I heard the one option something. I was trying. It is asking me to, hey, can you upload your file? So what I was doing, I was just trying to taking some help creating some the Gradle file. But I was in multiple Gradle files. I was just trying to create the common Gradle for it, and I was saying that which dependency I should take. So I was trying to analyze it. Then it asked me, can you upload your file? And then I will analyze and will tell you what to do. So this activity is not a Gen AI activity. It is a kind of RAG, right? You will give your own data and it will try to do something on top of that data. It is just like mix up. So I uploaded file and it started giving me the result. So that's what the activity I did, but I didn't do like that, that these are my project document, read it and tell me and summarize it. Okay. That we are doing manually only. Like, you will create a vector DB and you will take the embedding model and then you will push it and then you start asking the question after chaining the prompt and all these things, then you will do it. So that's how I'm doing now. Okay. But as you were telling, okay, no need to do, you have the documents just upload it and you start chatting with it.
Yeah, so basically all these GPTs and all these models are now agents. Under the hood, they are agents. They are doing all the tool calling by themselves
Mm-hmm.
and search. So they are not LLMs that we are talking about.
Yeah,
They
yeah,
are actually agents, and they have their own workflows already defined. So they can do RAG for you, because now they are managing they have in system memory too.
yeah, that is true. Now that's why the earlier version of ChatGPT or what it is like, you will they will based upon their knowledge only it used to give the information. Now it is giving the current information, like, it can ask the news or it can summarize the news for you. So that is RAG only, right? On time it is calling the tools or the going to the web search, then you giving the on fly, okay, latest on. So that's what the people used to do it earlier with the help of training model. But now even the ChatGPT also, audio option you will give. So they became like more and more agent now. They are not the LLM only, the basic or the classic LLM now.
Yeah, so the new thing is actually the multi-agent workflows,
Mhm.
or how to actually get multi-agents to talk to each other.
Okay. Oh yeah, that will be a bit complicated part, and I think the next focus will be just putting more and more data to these agents, right? More and more data and the complex things you will put it, then how you will get your work done or creating the workflow. That will be the next focus.
Yeah.
Yeah, I don't think that one agent will be doing a lot. It's just like you know, keep old wine in new bottle. वही वाली बात है.
Mm.
Like just like we had this microservices and all that architecture going on for last 20 years, right? Same thing
Yeah.
applies to AI agent also. So there are AI agents that do one thing and one thing very well, and then there are next level of AI agents that knows that, oh, there are these like grassroots level AI agent exists. How do I coordinate work among them to get some a little complex thing done, right? And they'll actually use LLM to decide that workflow, right? And then there will be on top of that, so there will be multiple hierarchies of AI agents,
Mhm.
and their capability will be based on what other agents they can use.
Yeah.
So yeah,
But the thing
well,
is that is the need, means are we living in such a world right now without LLMs, where we are uh, going to use multiple agent sort of thing, right? Okay, for example, agent is nothing but like a your the LIC agent or a uh, uh, and driving license agent, right?
hmm.
How is those scenarios are very rare. So those are
So
not those which are very much frequently used. Normally, a single agent means agent you can take it like your REST API server, right? So any application means how many REST API server are we using right now in our system design architecture?
so
Only
the way I look at it is that when users, simple users like us, when we are interacting, we would be always interacting with an agent which is actually trained or supervised for that task. Like let's talk about LIC agent, or at the bank, or at any other place, or shopping places at Amazon. At that point of time, we might not be encountering a multi-agent system, but there are these labs that are there, which are working on very big topics. At there, a hierarchy of, like what Manoj has said, a hierarchy of agents might be needed, and that place there are multi-agent systems might be needed.
No,
Many
even for
use cases
simpler
we can discuss on the use cases, but if we see the usability right now in the industry, right? How much it is feasible, or we are just making this concept as a hype. We are trying to generate more and more use cases of means how two agents can talk with each other, right? So it is good that we should know this topic, but at the same time we also uh, know that whether this is a feasible solution right now, or are we living in that world right now, or we are going to discuss something for the future.
And sir, if I will tell you from one thing I want to add from my side, I am just trying to do in currently in my project. Like so, I in the team. We have the one support team, and so what that does it, like we get some email. So one email the user say, hey, can you download me file for these one from S3 bucket and zip and send it to me. Another one say, hey, this is the ticket open, and based upon certain criteria, we need to close that ticket. Another one says, okay, this file get stuck, what is the reason, can you tell me the reason? So these are some limited SOP document we have, so around 20 page of the Word document, where we say, okay, this is the case, I will do this, this is the case, I will do this, this is the case, I will do it. I'm planning to do it. I started doing it, like one agent will look into my service now. Okay, if this is the criteria, close the ticket. Another one say, hey, this is the email, I need to download the file for this one, I need to reply, get me it. So one agent for it. Another agent, like if the file get stuck, I know how to get stuck. So all these things, like one agent for it, and there will be one supervising agent, like it will decide which agent need to reach out, and they will start working it. They will access my Outlook email, they will say, okay, this is the email came, nobody replied, let's take it and reply it. Okay, so that's what the flow will try to make it, like 2 3 agent, and one supervisor agent will work it and it will reply it. Okay, next thing,
Yeah.
maybe the bigger part of it, like putting the more different agent for, and something I am just trying, like one more thing, and the recently for the CV fix, like I have the some around 50 repo. In each and every repo, there is some changes. I need to change the version of the CV. So what it will do, they have the one security platform. So the security platform there, it will give me the list of the vulnerability in my project with all the environment. So one agent that it will go to the CV, get the all CV, go to the internet, find the solution for the CV, and the CV, okay, for this one, if you change this version of the CV, like change the Spring Boot version or this dependency, this will go. Okay, so that agent will do. And then another, and some piece of code is already written, like I will, in the same project, I can clone one. Okay, and then I can compile it, I can make the changes. So all these activities generally human being doing it, so we'll just trying to do it. Okay, so I believe, like where next decision need to be taken, that what should we do in this case, that LLM will do. Rest already written piece of code is there, like those are the some methods are there. Okay, it will direct, it will call that method and will try to do that activity. This is what my thought. I'm just started doing some pieces I did, and just trying to integrate the model to it. Hope in the coming days, I feel there may be some challenges will come when more and more different complex scenario will come, but hopefully it will work. Okay, I am
Yeah.
hoping it will work.
Yeah,
I
so
think we are at
for what
time now.
Radha is saying is that answering Deepak's question, that this is not futuristic, it is right here.
Now, when I'm running already behind schedule, I'm telling management, hey, I will do it, just give, because I already have something lot up in my plate, and I need to finish something. At the same time, this CV, I'm trying to fix it. They're saying, just, okay, don't do things, just fix it now. Okay, for now, then we'll talk later on. So once we'll do, then we'll just try to do it, like, that I need to change the version, need to compile it something, and just, next time everything integrated and let it do it by yourself. Okay, not only thing that I just want to something, it should submit the PR and it should email me. I will only review the PR. Merging I will do, because that review I will keep by myself. That whatever the fix it is applying, they are correct. But the build is success, tag generated, all the activity happens or not. Those one, but final control will be push from my side. So what is the, in my team now we are putting 50 CV, 5 each services, even more than that. How much? I'm just telling some, this is the real case. Okay, I have the 50 microservices on my project. Okay, every service is having 4 CV. We have the 10 environment, so you can say 50 into 10, 500. Everyone having the 5 CV, around 9,000 CVs are there. Okay, security vulnerability. For that, we have put around 10 people. For every service, they put a one user story, one resource, and that guy is taking whole sprint to fix it. Okay, if the same we do through the agent, I believe one or two guys are there. They just have the system. We don't need those 10 people just to do the. Even they are not able to do that activity in one sprint. The same can be done within 1 or 2 days if you try to put this agentic the things. Only thing that
So,
sometimes the particular services are having the issue that they are failing. Okay, the build is failing or some test cases are failing. That will take time. That anyhow, one expert guy is there. He can know how to apply the fix, and then he can take care of it. But this activity can, that's what the future I am seeing it. For in the coming days, I'm trying to apply within the next 1 month or two.
yeah, what to do next, right? So I
इसके
posted a
नेक्स्ट
poll
सेशन
on.
क्या बोल रहे थे मनोज? मेरे ख्याल से एमसीपी और A2A का एक रख लें क्या, जिसमें कि
हाँ, अभी what to do next, right? वही मैं बोलने वाला था कि I
हाँ,
posted a poll on the WhatsApp group. तो
चलो अभी
अभी
डिसाइड कर लो पोल में क्या
हाँ,
करोगे, आधे ज्वाइन करेंगे आधे नहीं करेंगे.
नहीं फिर भी मेजोरिटी
Maybe
ऐसा नहीं रहता चाहिए ना कि जो लोग चुपचाप बैठे हैं उनकी बात नहीं सुने. तो अभी मेजोरिटी कहती है कि कंटिन्यू दिस बुक. So if you have whatever you want to do, just put that poll and if majority says something else, then we'll do something else. Right now, it seems like people are really liking this book.
ठीक है चलो.
ये ऑप्शन कहाँ से आया था, मतलब कुछ
अभी लेकिन सर एक बात, अभी ये बुक भी तो खत्म करनी है. इट इज नॉट फिनिश येट, राइट?
हाँ, so we were discussing earlier in the beginning of the call that
लेकिन बुक
not
के जो
many.
और टॉपिक्स हैं वो इतने इंटरेस्टिंग हैं क्या?
अच्छा, एक काम नहीं कर सकते सर? कैन वी डू वन थिंग लाइक व्हाट एवर द वी डिड द थ्योरी पार्ट, इफ कैन वी डू सम काइंड ऑफ प्रैक्टिकल जस्ट टू बिल्ड द मॉडल. एक या दो कुछ प्रैक्टिकल हैंड्स ऑन क्लास कर सकते हैं कैसे?
Separate session for that.
इसी पे whatever the book we read till now, right? It is telling theory you need to do like this. वो personally I say I never did it, but I love to do that कि theory पढ़ ली है कि अगर डेटा मिले तो मेरे को मॉडल बनाना है, कुछ ऐसा करना है. तो at least if somebody did it and that's good, otherwise we can have some hands-on session.
Yeah, वो सब कर सकते हैं, but I think for now, because majority of the people want to continue this book, let's continue with this book.
चलो
Or whenever, like after a few chapters or maybe towards the end of the book, then we can discuss again what to do next.
अच्छा,
yeah, my vote would be Manoj ki this RAG. The next chapter is RAG, which is at least we should know before we even close this book.
Okay, that's good. Yeah, yeah.
So maybe we can punt it to the next week.
So next one is who's
Who's
taking
to-
the next session? Let me open the Nihar. I'll confirm with Nihar if he's good with that RAG chapter. If not, we'll find somebody else. He's not here today. ठीक है. We'll meet next week